equilibrium constant from the Nernst equation. Yes, we can also find out equilibrium constant for any redox reaction from the very simple Nernst equation formula. Now for this, let us take an example of a Daniell cell. And the Daniell cell, we know the reaction basically is like this. The zinc gets oxidized and it reduces copper. Now we know the cathodic half is of copper ions and the anodic half is having basically zinc and they are getting oxidized to zinc ions. Now at equilibrium, the concentration of both the sides becomes equal. Now once there is no concentration gradient, there is no potential gradient. As a result, therefore, no current flows in the circuit and therefore the E cell will become 0. It's not the E naught cell, it's the E cell, because at equilibrium the concentration already have changed, it's a non-STP condition. So E cell becomes 0 and your reaction quotient become equal to your equilibrium constant, or we can write your Q becomes equal to Kc, because we represent the equilibrium constant in terms of Kc, concentration. So therefore the Nernst equation can be written as, therefore at equilibrium the Nernst equation becomes, the Nernst equation we already know will be E cell equal to E naught cell minus 2.303 RT NF log Q. Now this, since E cell becomes 0, your E naught cell will be minus 2.303 RT NF log Kc, or the E cell will become 2.303 RT NF log Kc. So this is what is the main expression, and from here, from the value of the E naught cell, we can find out the value of the equilibrium constant. Also, another important thing, at 298 Kelvin, we know that whole of this 2.303 RTF, this whole term is actually 0.0591. So therefore this equation can be written as 2 E naught cell will be 0.0591 by N log Kc. So this can be used to find out this expression, the equilibrium constant of any redox reaction which is taking place in any of the galvanic cells at 298 Kelvin. We can easily find out from the E naught value its equilibrium constant. Let us see a numerical how we can find out the value of the equilibrium constant from the E naught cell value for any galvanic cell. The numerical is find Kc for the Daniell cell at 298 Kelvin having E naught cell 1.1 volt. So for the Daniell cell, the E naught cell value is given to us, it's 1.1 volt. And we know that for finding out the equilibrium constant for any electrochemical, for any galvanic cell, the E naught cell is equal to at 298 Kelvin, it will be equal to 0.0591 upon N log Kc. Now N for Daniell cell we know is zinc, because it is 2, because zinc ions loses 2 electrons and copper accepts 2 electrons. So exchange of electron is of 2 only electrons, that's why N is 2. So E naught cell is 1.1, 0.0591 upon N is 2 and log Kc. So log Kc becomes equal to 1.1 into 2 upon 0.0591, which comes out to be 37.3. So Kc is equal to NT log of 37.3, and when we do the NT log of this one, we will see in 0.3 which is approximately 2, and 37 becomes 10 to the power 37. So this equilibrium, the equilibrium constant for the Daniell cell is this much. It's so much big. And now from here you can clearly imagine that how spontaneous these redox reactions are, which are having such a large value of the equilibrium constants. So this is how we can use this information of finding out the Kc for any particular redox reaction or for any particular galvanic cell.